Welcome to Maths and Science by IITian channel. In this lecture, I would like to take up matrix inverse. How to find out matrix inverse in a traditional manner with the help of determinants, transpose, cofactors transpose, and from adjoint of a matrix. This is a traditional method of finding the matrix inverse. I had already discussed about matrix inverse from Cayley-Hamilton theorem, that is characteristic equation that's made equal to 0, that lambda in the characteristic equation is replaced by the matrix, that is Cayley-Hamilton theorem, and then we will find out the inverse. That procedure I have already explained in my previous lectures. And another method was like with the help of elementary row operations, and we will have a augmented matrix, and we will do the elementary row operation so that the original matrix will become a unit matrix or identity matrix, and the augmented matrix operations, the unit matrix will become the inverse of the matrix. That also I have explained with an example. In this lecture, I would like to explain you about finding the inverse of a matrix in traditional manner. It's a little bit cumbersome, a little bit lengthy procedure, but still we have to learn it. In the examination, any method can be applicable. If you know more number of methods, the most easily applicable method you can apply. This may be a traditional method. Sometimes this may prove to be useful to you in the examination on the basis of the matrix. Let us go into the details how to do it. Let us say the question is find the inverse of a matrix using adjoint. First of all, we have to know what is adjoint. Then for that, we are supposed to know what is a determinant and what is a matrix, and then from the matrix we have to find out what is a cofactor. From there we will find out the adjoint of a matrix. Then only we will be able to understand the inverse of a matrix. Now, for example, a matrix is there. Let us solve one by one, step by step. There is a matrix A11, A12, A21, A22. Or we can say we can take even 3 by 3 matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. Let us take a 3 by 3 matrix, 3 by 3 square matrix, where its determinant is not equal to 0. Then only this method can be applied. That means the matrix is non-singular. Determinant is not equal to, determinant is written like this, like delta A is not equal to 0. This is the condition. When delta A is not equal to 0, the inverse of a matrix is written as I told you, we have to find out the adjoint, then determinant, and determinant should not be equal to 0, then inverse of a matrix is equal to adjoint of a matrix, adjoint of that matrix divided by determinant of that matrix. Determinant can also be written as absolute value of A, like that also we can written, or delta also we can write, either way. Here it is called as determinant, and this one is called as adjoint. As far as the denominator is concerned, denominator should not be 0 to get the A inverse. That is the first and foremost condition. Very important condition. In this method, if you want to find out the inverse of a matrix, not only in this method, for an inverse to exist, determinant should not be equal to 0. An invertible matrix, determinant should not be equal to 0. When determinant is not equal to 0, that implies it's an invertible matrix. Invertible. That means we can invert it. Invertible matrix. Now, one by one let us analyze what is adjacent. What is adjacent of A? Adjacent of A is what? This is our question. Adjacent of a matrix is the transpose of cofactors. Transpose of cofactors. What is a cofactor? Cofactor is equal to it is a very important one. Please try to remember it. The value of determinant when ith column and jth row of the element under consideration are deleted from the matrix, and this value is multiplied by minus 1 to the power of I plus j. This is cofactor of an element. Aij. Cofactor of an element Aij. This is the definition. Please remember it. Now, we have taken the example A11, A12, A13, A21, A22, A23, A31, A32, A33. Now, these cofactors whatever are there, they are represented by capital letters of that particular element. Capital letters. Now, let us write the cofactor. Cofactor of, let us say, A12. What will be the cofactor of A12? A12 has I as 1 and J as 2. What we should write first? Minus 1 to the power of I plus j into determinant of ith row. Ith row is this one. And jth column is second column. You remove this, how the matrix will become? A21, A23, A31, A33. Then determinant of A21, A23, A31, A33. This is cofactor of, this can be written as A12, capital A12. Cofactor of A12 is equal to minus 1 to the power of I plus j, A21, A23, A31, A33. What is I? I is equal to 1, j is equal to 2. That can be written as minus 1 to the power of I plus j is 1 plus 2. Determinant of A21, A23, A31, A33. This will be minus 1 to the power of 3. Minus 1 cube is minus 1 into determinant will be A21, A33, that is cross multiplication. Minus these two cross multiplied and these two cross multiplied. Minus A31 and 1 is first one, from first one, second product is subtracted. A31, A23. This is the procedure how for a particular element, this is the element here, this is the element here. For this is the cofactor. Similarly, the cofactor of A31, let us say, you can do for anything. Minus 1 to the power of 3 plus 1. Do not change the order. Do not change the procedure. Same procedure, same order. People may tell about some shortcuts. Let's not go by the shortcuts here. The hard way only is better, because that only gives the correct answer. In shortcut what happens? There will be a confusion. Don't go by the shortcuts, particularly in this method. If you want to really go for shortcuts, choose other methods. In this method, don't go by shortcuts. That's my advice only. Minus 1 to the power of 3 plus 1 into determinant of, this is A31. A31 means we have to remove this. Sorry, let us say with this blue ink, let us say A31. Third row and first column. What is left over? Third row, first column, when we have removed A12, A13, A22, A23. minus 1 to the power of 3 plus 1 is minus 1 to the power of 4 into determinant cross multiplication a12 into a23 minus a22 into a13. This is the value. Minus 1 to the power of 4 is plus 1. That is equal to a12 a23 minus a22 a13. This is how, once we have got all the cofactors with us, then what will be the cofactor A? Cofactor A will be A11, capital A11, cofactors are capitals, A12, A13. For each and every element there will be a cofactor, A21, A22, A23, capital A, A31, A32, A33. Then transpose of cofactor. Transpose of cofactor matrix is equal to adjoint of the matrix. This is very, very important. This is the most important step. Once adjoint is known, then you can, once cofactors are known, you can find out the determinant. Once cofactors are known, what is the formula for the determinant? Please recollect. Once cofactors are known, take a row or column, and for each you find out the determinant of, by deleting the row and column, you find out the determinant, multiply with that element plus or minus and add them. I will give one formula. That particular element determinant is equal to A11 into A11 plus A12 into A12 plus A13 into A13. This is the determinant. Once you know the cofactors, you multiply the cofactors with the corresponding elements and you will get the determinant of the matrix. This can be done with the columns also. When you do it with columns, either take one row or one column and multiply each element of the row with its respective cofactor and sum it, or it is with rows when you use the row 1. When you use the column, A11 into A11 plus A21 into A21 plus A31 into A31. Capital A is cofactor, small a is the corresponding element. Either you take a row or you take a column. That's up to you. And whichever you feel it is easy to operate. This is using column 1. Now you have got the determinant. You know delta is equal to A is equal to, this is determinant. You got the determinant. You got the adjoint. Adjoint is transpose of cofactors matrix transpose. This is adjoint. Adjoint of A, cofactors of A, we can say. Here we can say determinant of A, because determinant of what? Then A inverse is equal to 1 by determinant of A into adjoint of A. If you feel as per the given situation and question in the examination, if this method is, we are easily able to do, with this method easily find out the A inverse, means go for it. Otherwise, from my experience, what I share is, better go for first is to go for row and column elementary operations, and with the help of augmented matrix find inverse. Second method, go for Cayley-Hamilton theorem, characteristic equation, and from that you find out the inverse. Third is, from adjacent A find A inverse. These are the three methods. We can find out the inverse, and whether a inverse is a singular or not, that matter you find out the determinant. And product of the eigenvalues is equal to determinant. That is one property. Many properties I have explained about the trace, eigenvalues, eigenvectors in my respective lectures. Please refer to them. Now, this is the way we have to find out the inverse of a matrix. I will go for a simple 2 by 2 matrix. Then for practice purpose, you go for higher level, higher order matrices also. Order is how many rows and how many columns, that is the order. Higher order means 3 by 3 matrix, 4 by 4 matrix, 5 by 5 matrix. Here I am going by 2 by 2 matrix. Let us say a matrix A is equal to, just for the sake of example, 1, 3, 5, 6. Find A inverse. Now, here I will explain the step by step method. First step is to find the given matrix is invertible, because if it is invertible, then only we can find out the inverse. Otherwise we can't find. Inverse does not exist. Whether inverse exists or does not exist, we have to find out whether it is invertible or non-invertible. For invertibility, for inverse to exist, delta, what is that condition? First condition is very important condition, determinant delta A should not be equal to 0. Here, what is delta A? That is determinant of A. What is its value? 1 into 6 cross multiplication, as I have already put the arrows. 1 into 6 minus 5 into 3. That is equal to 6 minus 15. That is equal to minus 9, which is not equal to 0. Hence, the matrix is invertible. Matrix is invertible. Now, what is the next step? Determinant is there. We have to find out the adjoint of matrix. To find out the adjoint, we have to find out the cofactors. Second step is find cofactors of each element. Let us say this is A11, this is A12, this is A21, this is A22. The cofactor of A11 is equal to minus 1 to the power of 1 plus 1, because I is 1 and J is 1, into what is the cofactor? The determinant. When you remove first row and first column, what is left over? 6 is the left over. If it is a 3 by 3, remove respective column and row and take out the remaining matrix and find out the determinant. If it is 2 by 2, the value is direct. Now, plus minus 1 to the power of, for A12, let us take a row. Let us take the row. Okay. This is about determinant we are talking about. No. A11 is equal to minus 1 to the power of 1 plus 1 into 6. Now, what is A12? A12 is equal to minus 1 to the power of 1 plus 2 into 5. Do you agree? This value is equal to 6, this value is equal to minus 5, and A21 is equal to minus 1 to the power of 2 plus 1 into leftover is 3, that is minus 3. Then A22 is equal to minus 1 to the power of 2 plus 2 into A22, and you remove the row and column, then 1 is left over, that is plus 1. That means what we have got the values, we will write the cofactor matrix. Cofactor matrix of A is equal to A11 is 6, A12 is minus 5, A21 is minus 3, A22 is plus 1. Then cofactor matrix transpose is equal to adjoint A. This transpose of this will be 6, columns will become rows and rows will become columns. 6 minus 3 minus 5, 1. This is the adjoint A. Then what is the inverse? A inverse is equal to 1 by delta into adjoint A. That is equal to 1 by minus 9 into 6 minus 3 minus 5, 1. When a matrix is multiplied by a scalar, every element of the matrix is multiplied by a scalar. Then what will be the value of A inverse? A inverse is equal to minus 6 by 9, minus 3 by minus 9, minus 5 by minus 9, minus 1 by 9. That is equal to minus 2 by 3 this minus minus get cancelled, that is 1 by 3, minus minus get cancelled here also 5 by 9 and here it will be minus 1 by 9. Ultimately, this is the inverse of the matrix. This is one method. And let us do Cayley-Hamilton method. Whether you get the same answer or not. Let us validate Cayley-Hamilton theorem. Cayley-Hamilton theorem. Because it is a non-singular matrix, matrix is invertible, it is a square matrix. Cayley-Hamilton theorem can be safely applied. Cayley-Hamilton theorem says characteristic equation is equal to 0. What is the characteristic equation? A minus I lambda is equal to 0, determinant of it. What is A minus I lambda? A minus I lambda is equal to, what is A? A is 1356. 1356 minus 1356 minus lambda into I, 1001. This will be A minus I lambda, determinant will be determinant of 1 minus lambda, because minus lambda into 1 is minus lambda. And 3 minus 0 is 0, 0 into lambda is 0. Hence 3, 5 minus 0 into lambda is 0, that is 5 remains same. And next 6 minus lambda, this is equal to 0. This makes 1 minus lambda into 6 minus lambda, the determinant will be minus 15 is equal to 0, cross multiplication. Then what it happens? 1 minus lambda into 6 minus lambda is lambda square, minus 6 lambda minus 1 lambda is minus 7 lambda, one into 6 is plus 6, minus 15 is equal to 0. That means lambda square minus 7 lambda minus 9 is equal to 0. Do you agree? That implies lambda square minus 7 lambda is equal to 9. Replace lambda with, next step is replace lambda by matrix A. That implies A square minus 7A is equal to, multiply the constant with I, 9I. Then multiply both sides with A inverse. A square into A inverse will become A minus A into A inverse will become, we'll write that step for your convenience, A square into A inverse minus 7 A into A inverse is equal to 9 into A inverse, because I into A inverse is A inverse only. That means A square into A inverse is A, 7 into A inverse is I, A minus 7I is equal to 9 A inverse. When you, then it becomes A inverse is equal to 1 by 9 into A minus 7I. That is A inverse is equal to, it is simplified. What is A? A is 1356 minus 7 into 1001. Add these two matrices. 1 by 9 into 1 minus 7, because individual elements to be added separately. 3 minus 7 into 0 is 0, 3 minus 0 is 3 minus 0. 5 minus 7 into 0 is 0, 5 minus 0. 6 minus 7 is, 7 into 1 is 7. That means 1 by 9 into minus 6, 3, 5, minus 1. That is equal to minus 2 by 3, 5 by 9, 1 by 3, minus 1 by 9. Which is same as the answer which we have got from the previous method. These are the two methods, and third method is also there, which I have told you. I have explained with the 3 by 3 matrix well, so that you can apply it. Row and column matrix you can find out. Take it as a homework. Check the value of A inverse by using elementary row and column matrix operations, and cross check with the above value of A inverse. Validate. This is the third method which I want to give you as a homework. If you have any problems, you can check with me, comment on the comment column in the description. And another thing, why I left it as a homework, because the next topic which I am going to take is very, very important topic, rank of a matrix. By finding the rank of a matrix, you can find how many solutions for a simultaneous equations are there. This is the foundation for simultaneous equations topic. This is one of the major topics in linear algebra and matrices. On the simultaneous equations, there are huge number of questions being asked in JEE Mains, JEE Advanced applications. Every year there will be some questions. Every year. Very important topic. If any of the inverse and other things they miss in the exam, but simultaneous equations do appear. Very important, because it has got lot of engineering application, lot of science applications, physics applications, lot of research applications, solving ultimately why we are doing this matrix linear algebra, to solve the simultaneous equations. This topic I will take up after a class on the rank of a matrix. If you understood till now, to find the inverse, then I will go for the rank with the help of the elementary row, and for that only I left this row and column elementary operations as a homework to you. Try to understand before understanding the rank of a matrix, for finding the solutions for simultaneous equations. With this, I want to close this lecture now. Best of luck to everybody. Please take each and every step in this very carefully. Don't make any mistakes in the examination, and ensure that you follow the procedure and obtain the correct values. Because if you skip any steps, then we may not get the correct answer. For that only, I repeatedly tell you, it is not the fastness in mathematics, it is the accuracy in mathematics that matters more. It is the concept in the mathematics that should be understood well, and accuracy in doing the mathematics with zero mistakes, nil mistakes. Our target should be zero mistakes in the examination. Best of luck. Thank you for viewing my lecture. If you feel there is a value addition to your knowledge because of this video or lecture, please share my channel details to all and subscribe to my channel Maths and Science by IITian. Next class will be very, very important. That will be rank of a matrix. Even though it may not be spelt as a rank of a matrix in your syllabus, but directly, indirectly, the simultaneous equations are influenced by finding the rank. How to find the rank, what is the meaning of the rank, and by finding the rank of the matrix, using the matrix operations and matrix properties and determinant operations and determinant properties, how to find out whether a particular simultaneous equations, set of simultaneous equations, they behave. That is the motive behind it. Once we know the behavior of the simultaneous equations, to solve them is not a big task. Many questions are logically asked instead of being asked to solve the equations. They may ask how many solutions are there, infinite solutions, no solutions, solutions are not possible. This type of logical questions are being asked in the simultaneous equations because of its importance in the engineering and science applications in future studies. Best of luck. Thank you for listening to me.